Hello everyone. In this video I want to show you three advanced commands for getting inputs from the user. So you probably all know the command input, right? So you can say, for example, n equals input and then provide the text and say, for example, enter a positive integer and wait for the user to enter a number and then get it and assigns it to n, right? That is a very simple thing, and it just based on a simple text that you show and the number that the user enters. Now, the advanced commands, one of them is menu. So here you provide a bunch of selections for the user to choose one from, and then based on what the user chooses, in a graphical window, you can basically infer the selection. So let's say, for example, I go ahead and I want to allow the user to select from one of the three colors, right? So I say colors equals in a cell, and then say, let's say red, and then, for example, yellow and gray. Right, and then I use the command menu and then provide the title, let's say color, right, color to choose, and then I provide this cell colors to it. So this should provide me a window, right, and it allows me to select a value, right, let's say value equals that, and then assign it to this value. So let's go ahead and run this one. So you see here I have this window and it allows me to select the color, and I say, let's say I want yellow, so I click yellow, and you see value is chosen as 2. 2 means the second of these, the second entry of this vector. So now what color was really chosen? The second color, yellow. So the color that was chosen was colors of what? Of val. This is the color that was chosen, right? So if I basically show it, you see that was yellow, huh? So for example, you can say display or fprintf or something like that. Display you chose, and then display and then colors with value. Okay, so this is, let's say this time we choose gray, and you see it says you chose gray. So this is menu, providing a graphical basically option. The second one is if you want to get the address and name of a file using a browse window. So here, let's say I want to read an image and I want to know the name of it and the address of it, and I want to get it by opening a browse window, so we can go over that image and just click on it, and this uigetfile is going to do that for me. So here that file and path is equal to uigetfile, and that's all. You don't need to pass to it any input. Okay, so if I just run this, look what happens. So it opens this browse window, and here you can choose what type of files, let's say all files, and let's say this is the image that I just took from my channel. So I want to read that into MATLAB and show it. So if I choose that and say open, it's not going to open the image, it's just going to assign the name of it and the address of it to these two variables, file and path. Look, you see, so file name is eea.jpg, and the path is under my downloads, right? So if I really want to read that image and show it to you, I have to say image equals imread. I have to use the command imread, and since I need both the path and the file right after each other, I use a concatenation. So I say path and then file, so it puts them right after each other. It reads the image, and then I say what? show image. Okay, so now if I do this, that should do the job. So let's go ahead and do it again and read this image, and it should read it, and there we go. It can show the image here. Okay, so opening a browse window and getting the name and address of a file can be done graphically by uigetfile, which is an interesting command. Finally, ginput. This is an interesting command that when you have a picture or a graph or anything, if you click on as many points as you want, it gives you the location XY of the points that you clicked. Okay, and you might say, what's the use of that? Well, one application is, let's say I want to recreate this plot here. So I got this graph from the internet, which is like the world population history versus the years, let's say from 0 to 2000, right? And the numbers are in billions. And let's say I just got this as a single picture from Google. Now I want to recreate the plot like that. Okay, I want to get this data and I want to recreate this plot. Okay, first of all, you see this image is small, right? So I really might want to resize the image when I read it into MATLAB. And then this ginput allows me to click on as many points as I want by mouse. It gets all of the coordinates of those points, and then I can use those points to create this kind of graph. Okay, so let me show you how I do it. So here I say the image is what is the image. Let's use get file again, right? So we're going to use that get file and read it. And this time I'm going to show it as well. So the same thing. And then we're going to use the ginput command to allow us to click on a bunch of points. Let's say, for example, 20 points, okay? Something like that. It gives us X and Y, and then I'll show you how to use those X and Y to generate the same graph. So here, let's go ahead and first do this part, okay? And this time I'm gonna read this graph, okay? I read it in, so now the image is that one, right? Now the image is still the previous one, okay? Still that big image. So if I read the image right now, if I run the second command, you see my image is small, 242 by 400. So maybe before I show the image, I want to resize the image. So say image equals IM resize of the image and a scale factor of 3, and maybe I use the bicubic method, which is one of the best methods for resizing. So first, I'm going to make that 242 by 400. Let's go ahead and make it 3 times bigger. You see, 726 by 1200. Now I'm going to show the image. There we go. And now when I run this command, it allows me with the mouse to click on 20 points and capture the coordinates of those points. So let's go ahead. You see now the mouse becomes like a crosshair. And to do it correctly, you want to also, one of the points you want to click in is 0 and 0. Okay, that might be a good point to do, because that will tell us where the zeros are. So here, this point does not need to be on the graph, this first point. I click here, and then I start clicking on the first point on the graph. So that's 2 points, 3, 4, 5, right? Try to click on the blue point, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and let's just end it at 2000, maybe right here, 20. And you see the crosshair disappears because I clicked on 20 points. And now if I go back, you see I have X and Y, 20 by 1. And if I go and show you this X and Y right next to each other, you're going to see that the values are not the values in that picture, right? They are not like 0 to 2000 for X and 0 to like 7 billion for Y. If you look at the first point that we clicked on, or the first point of the graph, you see this number is what? Is 1000 times 141. So the first point on the graph, not 0, 0, the first point on the graph is 141 for x and 610 for y. And you might say, where do those numbers come from? 141 and 610? What do they have to do anything with these numbers on the graph? They are not really. If you use the data cursor and click on this point here, you'll see that those data are actually the pixel coordinates. Look here, 141 and 605, you see? So something like that. So they are really pixel coordinates that we clicked on and not real data points. So now if I want to convert those pixel coordinates to the data point, I need to do some transformation. So what is my transformation? Well, remember that x number 1, which is 140, corresponds to 0, and the last x I clicked on, which is 1050, that's correspond to what? The maximum x, which is 2000. So I need to go from one range to another. So here I define a new x, and that is going to be basically x of 2 to end, because remember the first x we don't really need, okay? That's just there to give us some information. So x of 2 to n, these are the real curve data, minus x of 1, which is 0.0, divided by what? Divided by x of n minus x of 1, because remember x of n corresponds to 2000, x of 1 corresponds to 0, and here this is a linear transformation, which if I just go with this, the numbers are going to be between 0 to 1. Is normalization. So I need to multiply that by 2000. So xn is going to go from 0 to 2000. And now if you look, you see here, the first number is like 22, and it keeps increasing all the way to what? 2000. So my xn is properly what? Mapped from the first x to last x, it mapped properly to 0 to 2000. Now my y values, their minimum is somewhere here, right? And their maximum is somewhere here. So the maximum is somewhere like close to 7 billion or something, right? And the minimum is here. And now if I want to give this range, how much is it? How much it is right now? So let's say at 2000 it is about 7 billion, and at 0 it is like 0.2, so it's like corresponding to roughly 6.8 billion. Okay, so now how do I transform the y? With a similar manner. So I say y equals, and then here again you need y of 2 to end minus y of 1 divided by y of end minus y of 1. Okay, but this time the range, as I said, is like 6.8 e to the 9. Now if I do that, what's going to happen? Well, if that is what I will have, okay, let's click on it, see what happens. You see my maximum data is going to be 6.8 e to the 9, and my first data is going to be not 0, which is what I really want. Okay, so now right next to this graph, and let me make this a little bit smaller. If I go ahead and say figure, and then say plot this xn and yn, and maybe line width and 3. Let's see if that will generate something similar to that graph for me, and you see it does. Look here. See clearly that the graphs are similar to each other, right? And the only thing you might just want to add to this graph on the right is X label, Y label, a title maybe, and maybe these horizontal bars. So if I want to make my code complete, right, I go back here. I did this basically a linear conversion. Just add this x label x, and then well, not x really, year, and y label to be like population in billions, and then title is going to be like word population history graph recreated using ginput. Okay, so now this should do the job for me. So if I have this one and I add these guys to it, you see here I got all of those, and you might say, well, how would you add those horizontal line? So all you need to do is to use the axis and then use uigetfile command. Let me show you that one as well. So you say axis equals to the current axis, GCA, and then axis.yGrid on. Just turn the Y grid on, not the whole. You don't say grid on because it turns all of the lines horizontal and vertical. But if you say axis.yGrid on, then it just turns on the horizontal lines. And to make the range of axis of the new figure the same as the picture, I use this range here, right? So hopefully if I do this, that will, there we go, create something that is comparable, right? There we go. So you see I could create a graph very similar to my picture using the ginput command. So hopefully this video was useful to you, and I'll see you in my next lecture. Thank you.